Hey guys, so welcome back, and it's really good to see you guys here. And if you have been following my previous videos, you know my name is Priya Singh Rangey. I am an assistant professor at the LJ Institute of Physiotherapy, and I have done my masters in physiotherapy and rehabilitation. And on this platform, we talk about biomedical physics. So if you have been watching my previous videos, you have an idea that we have been talking about all the different kinds of things in physics. We have been talking about static electricity, we have talked about conductors, insulators, we have also talked about semiconductors and the different valves, that is the diode valves and triode valves. And so we'll be running on the same lines today, and we'll be discussing two important laws that are found in physics that almost all the different electrical circuits of different appliances need to follow. That is the Ohms law and the Joules law. So we'll be discussing about the Ohms law, we'll be discussing about the Joules law, and we'll also be discussing two different arrangements, two important arrangements of electrical circuits. We will be discussing the resistance in series arrangement, and we'll be discussing the resistance in parallel arrangement. So let's begin with the Ohms law. The Ohms law states that there is a constant relationship that exists between the magnitude of the current that is being carried by a conductor, the electromotive force that is being applied to a conductor, and the resistance that the particular conductor possesses. So here we are talking about three different parameters of a conductor and a circuit. We are talking about the current that is being passed through the conductor. We are talking about the EMF or the electromotive force that is being applied to the conductor, and we are talking about the resistance of the conductor. And the Ohm's law states that there is a constant relationship between these three parameters. Now, what is this relationship? The Ohm's law states that the magnitude of current is going to vary directly with the electromotive force or the EMF, and it is going to vary inversely with the resistance of the conductor. So in simple terms, if I want to denote this in the form of an equation, I can say that I, that is the intensity of current, will be equal to E, which is the EMF or the electromotive force, divided by R, which is the resistance of the conductor. So I will be equal to E upon R, or I will be equal to V upon R, where V is the potential difference that lies on the two ends of the conductor. So this is what the Ohm's law states. Now on lines of the Ohm's law, we have two different kinds of arrangements that we see in an electrical circuit. These two different arrangements are the resistance in series arrangement and the resistance in parallel arrangement. Now when we look at the resistance in series arrangement, like you can see in the figure, when we say that the resistances are arranged in series, it means that we have all the resistances lying one after the other in a series inside the circuit. So when we are connecting this arrangement of resistance in series to a potential difference, what are we going to get? We are going to get a flow of current. Now when we talk about this current will have to pass through each and every individual resistance in order to move from one end to the other, that is to move from the positive end to the negative end. Hence, when we talk about the total resistance of the circuit, the total resistance would be a sum of the individual resistances. So say if we are saying that R is the total resistance of the circuit, then R will be equal to the sum of individual resistances, that is R1 plus R2 plus R3. And if we have multiple resistances, then so on. So whenever we have a resistance that has been arranged in series, the total amount of resistance that is being offered by this kind of circuit is increased. and not decreased. Hence, when we are using this kind of circuit, we can use it for different purposes like heating, since a higher resistance is going to lead to a lot of thermal energy being produced. Another arrangement that we see in electrical circuits is the resistance in parallel arrangement. When we say that the resistances are arranged in parallel, as we can see in the figure, you can see that the resistance R1, R2 and R3 are lying parallel to each other. They are not in line with each other. So whenever there is a parallel kind of arrangement, the current gets alternative pathways to flow. That is, say if we consider I to be the current, the magnitude of current that is flowing through the circuit, I amount of current is going to have three options. It can pass through R1, or it can pass through R2, or it may pass through R3. So ultimately what happens that there is going to be a division of current. Some amount of current will pass through R1, some will pass through R2, some will pass through R3. Not the entire current will be passing through all the resistances, as we have seen in the resistance in series kind of arrangement. So ultimately we get a division of current, that is the current gets divided into I1, I2 and I3. The proportion of current that flows through each pathway will depend on the individual resistance that is being offered by the pathway. The lower the resistance of the pathway, the higher is the amount of current that will be flowing through that particular pathway. So what occurs is that the smallest amount of current passes through the largest resistance, and the highest amount of current passes through the lowest resistance. The benefit of this kind of arrangement is that when we talk about the total resistance is going to be the inverse of the total resistance is going to be the sum of the inverse of the individual resistances. So if we say that the total resistance in this circuit is going to be R, then 1 upon R is going to be the sum of 1 upon Rm, R1, 1 upon R2 and 1 upon R3. So the total resistance that we get here would be less than the individual resistances that are being applied, since the cross-sectional area of the pathway is increased. So the benefit of using a resistance in parallel kind of arrangement is that we get lesser amount of resistance that is present inside an electrical circuit. So these are the two different kinds of arrangements. Next, moving on to the Joules law. The Joules law is a law regarding the heating or thermal energy that is being produced in a circuit. The Joules law states that when current is passed through a conductor, some electrical energy is transformed into thermal energy. So whenever a current is passing through a conductor, we do not get complete conductance of the electrical energy from one end of the potential difference to the other. There is some amount of energy that will be dissipated in the environment in the form of thermal energy. Now this occurs because there is a collision that is occurring inside the material between the electrons that are moving and the ions that are present in the conducting material. This collision or this friction between the moving electrons and the ions of the conducting material ultimately leads to release of thermal energy. This thermal energy, or the amount of heat that is produced in the conductor, is going to be proportional to the square of the current, the resistance and the duration for which the current is going to flow. So in simple terms, if I want to denote this in the form of an equation, I can say that Q, that is the amount of heat that is produced, is going to be equal to square of the current, that is I square, resistance, that is R, and T, that is the duration. So Q is equal to I square RT is what the Joules law wants to state. So by using this equation, we can determine the amount of heat that is produced in each and every circuit, and we can also understand what we can do, or what possibilities there might be in order to increase the amount of heat that is being released in a circuit, so that we can get more amount of heat production and we can get more amount of infrared and ultraviolet radiations. So this can be used in order to enhance the performance of our electrical circuit. So these were the two important laws of biomedical physics that we discussed here today, the Ohm's law and the Joules law, and the two different kinds of arrangements that we can see in an electrical circuit. Hope after this video you will be able to understand the electrical circuits of different physiotherapeutic equipments better and more easily, and you will be able to learn how all these different laws can affect the mechanism of our different modalities and different equipment. So signing off, please refer my other videos to get more knowledge about biomedical physics and how the different physiotherapy equipment work. Thank you.